Here we have the same type of problem as that in examples 6 and 7, but we have a different series altogether. In this one, we're told that x is equal to 3.9. And again, we want to find out where this series, where we put in x equals 3.9, n to the 3.9. We want to know where that sits in the hierarchy and whether it converges or diverges. There we are. All right, so again, we'll start with n to the 3.9 plus n squared plus n to the 5th plus n cubed plus n. Pull off the dominant terms, n to the 3.9, n to the 5th. This is similar to 1 over n to the 1.1. And you might say, how did I do that? So here I'm using a rule. This is a rule for exponents. If you have x to the m over x to the n, this is 1 over x to the m minus n. So this is 1 over n to the 5 minus 3.9. That's how I get that there. Let's see, 5 minus 3.9, that is 1.1, right? Let's see. So before, and then, yes, that's right. Okay. Oops, 1.1, not 1.5, 1.1. All right, so we know that due to this fact, we know that there are two associated series, either both converge or both diverge. So we'll look at, so n to the 3.9 plus n squared plus n to the 5th plus n cubed plus n, and the sum or series 1 over n to the 1.1. All right, so both of these series either both converge or both diverge because their rules, the sequences defined by their rules, are similar. They're related by tilde. This again is a p series with p equal to 1.1, which is bigger than 1, and p series with p bigger than 1 converge. So since this converges, we know that this converges. And so we have convergence. We also know that because of this fact, they both sit in the same place in the hierarchy. So because one over n to the 1.1 goes to infinity slower than 1 over n to the 1.01, right? And this is because, again, we're dividing by more, right? N to the 1.1 is a little bit bigger, or 1.1 is a little bigger than 1.01. So n to the 1.1 is a little bigger than n to the 1.01. So then dividing by a little bit bigger makes you a little bit smaller. Now maybe this is a little confusing, so what you want to do is use this rule, right? We know, so this is saying the same thing as n to the 1.01 goes to infinity slower than n to the 1.1. And this we can verify is true, right? Like remember, as just an example, n squared goes to infinity slower than n cubed, right? That's because 3 is bigger than 2. And so in the same way, n to the 1.1 goes to infinity faster than n to the 1.01. That's because 1.1 is a little bigger than 1.01. And now using this rule where if you put 1 over them, it flips the order, right? So this thing went over there, this thing went over there. All right, so now we know that. So that means that this, and since this thing sits there, the series that we're actually interested in, this one, has to sit there as well.